Okay, so I have a maximization dual problem now that I need to solve so that I can solve the minimization problem that we were really truly given. So I'm going to solve this the same way we've done in the past. I'm going to add my slack variable, so I have x1 plus 2x2 plus s1 equals 8, 5x1 plus 2x2 plus slack variable 2 is equal to 16, and then my constraint, I'm going to have negative 9x1 because I'm moving the 9x1 and the 10x1 to the other side of the equation. So when you move them to the other side of the equation, they become negative, plus z equals 0. Now I can put that into my initial simplex tableau. So I have 1, 2, 1, 0, 0, 8. And then 5, 2, 0, 1, 0, 16, negative 9, negative 10, 0, 0, 1, 0. And I want to decide which column is going to be my pivot column, so I'm looking for the largest negative indicator. The largest negative indicator is 10, so x2 is going to be my pivot column. To decide which row is my pivot row, I'm going to take the constant term 8 and 16 and divide it by the values in the pivot column. So 8 divided by 2 is 4, 16 divided by 2 is 8. Between 8 and 4, 4 is my smallest. So we're looking for the largest indicator to pick the pivot column, but we're looking for the smallest quotient, positive quotient, to be the pivot row. So my pivot value is going to be the 2 in the first row, second column. First thing I want to do is make that 2 into a 1. So the way I do that is I'm going to take the reciprocal of 2, which is 1/2, times row 1, and put it back into row 1. What I'm going to do to save myself a little bit of space is I'm going to put my matrices right underneath each other so I don't have to keep writing the labels at the top. I know that the first row is going to be my x1 because I lined them up so nice and neatly. Row 2 and row 3 aren't changing, so I'm just going to go ahead and rewrite those. But my first row is, I'm going to take 1/2 times all of the values. 1 times 1/2 is 1/2. 2 times 1/2 is 1. You can think of it as divided by 2 if you want. 2 divided by 2 is 1. 1 divided by 2 is 1/2. 0 divided by 2 is 0. 0 divided by 2 is 0. And 8 divided by 2 is 4. So I have now successfully got the 1 in the pivot value. Now I would like to get zeros above and below that. In this case, just below. So I would like a 0 where this 2 is. To get a 0, I'm going to take the opposite of 2, which is negative 2, times the row with a 1 in it, in this case, which is row 1, and add the row back to row 2. So I'm going to take the first row and multiply by negative 2. 1/2 times negative 2, that's negative 1. Negative 2 times 1, that's negative 2. Negative 2 times 1/2, that's negative 1. Negative 2 times 0 is 0. Negative 2 times 0 is 0. And negative 2 times 4 is negative 8. Right underneath that, I'm going to put row 2, which is 5, 2, 0, 1, 0, 16. And then I can add down. This gives me 4, 0. No big surprise there. That's what we were hoping to have happen. Negative 1, 1, 0, and 8. This needs to go in the next simplex tableau. So I'm going to carefully rewrite this. Right underneath, I'm using the columns all the way down, so I'm not having to rewrite x1, x2, s1, s2, and z labels. And this is going to go in row 2. Notice that our green row 1 is going to stay the same, so I'm going to rewrite that. And now I need to get the negative 10 to become a 0. In order to get it to become a 0, I have to take the opposite of negative 10, which is positive 10, multiply it by the row with the 1 in it, which is row 1, and add it back to row 3. 10 times 1/2 is 5. 10 times 1 is 10. 10 times 1/2 is 5. 10 times 0 is 0. 10 times 0 is 0. And 10 times 4 is 40. Then I'm going to put row 3 right underneath it. Negative 9, negative 10, 0, 0, 1, 0. When I add down, I get negative 4, 0. No big surprise there. That's what we were hoping to have happen. 0, 140. And I'm going to put that in the bottom row. Now, to see if this is my final simplex tableau, I need to see if there's any more negative indicators. And there is. This negative 4 is another negative indicator, which means column 1 is going to be my pivot column. To figure out which row is going to be my pivot row, I'm going to take the constant column, which is the last column, divided by the pivot column. So 4 divided by 1/2. You can use a calculator if you want. That turns out to be 8. 8 divided by 4, that's 2. Between 8 and 2, we're looking for the smaller quotient, which is 2. Smaller positive quotient, I should mention. So row 2 is going to be my pivot row. Therefore, 4 is my pivot value. So the next thing I need to do is make sure that 4 is a 1. Again, I'm lining everything up very nice and neatly so I don't have to keep writing my column headings. To make that 4 a 1, I have to take the reciprocal, which is 1/4, times row 2, and put it back into row 2. Notice that row 1 and row 3 stay the same. So 4 divided by 4 is 1, 0 divided by 4 is 0, negative 1 divided by 4 is negative 1/4. 1 divided by 4 is 1/4, 0 divided by 4 is 0, 8 divided by 4 is 2. So now I have the 1 where I want it. The next step is to get zeros above and below that. So the 1/2 needs to become a 0, and the negative 4 needs to become a 0. So in order to get the 1/2 to become a 0, I'm going to take the opposite of 1/2, which is negative 1/2, times the row with a 1 in it, in which this case is that red row 2, plus row 1 back into row 1. So negative 1/2 times the red row is negative 1/2 times 1 is negative 1. Negative 1/2 times 0 is 0. Negative 1/2 times negative 1/4. That's positive 1/8. Use a calculator if you feel like you need to. Negative 1/2 times positive 1/4 is negative 1/8. Negative 1/2 times 0 is 0, and negative 1/2 times 2 is negative 1. And we're going to put row 1 right underneath it. 1/2, 1, 1/2, 0, 0, 4. Negative 1/2 plus 1/2 is 0. 0 plus 1 is 1. 1/2 plus 1/8. Go ahead and use a calculator if you want. 1/8 plus 1/2 is equal to 5/8. Negative 1/8 plus 0 is negative 1/8. 0 plus 0 is 0, and negative 1 plus 4 is 3. So I have a new matrix. Row 2 is going to stay the same. That's the red row. So I have 0, 1, negative 1/4, 1/4, 0, and 2. My first row is going to be replaced with the 0, 1, 5/8, negative 1/8, 0, and 3 that I just calculated. And now I need to get that negative 4 to become a 0. So the opposite of negative 4 is positive 4. Times the row with the 1 in it, in this case is row 2. Add it back to row 3 and put it in row 3. So we have 4 times the red row, which is 4 times 1 is 4. 4 times 0 is 0. 4 times negative 1/4 is negative 1. The 4's divide out. Positive 1/4 times 4 is positive 1. 0 times 4 is 0, and 4 times 2 is 8. Then I'm going to put the row 3 right below it. And then add down. That gets me 0. No big surprise there. That's what we were hoping to have happen. 0, 4, 1, 0, and 48. So we have 0, 0, 4, 1, 0, 48. I know that my maximization problem is done because there's no more indicators. So let's go ahead and see what the solution to that is. I'm going to rewrite my labels here, x1, x2, s1, s2, z, and then the last column is the numbers. Notice that my basic variables are x1 and x2. That means s1 and s2 are going to be my non-basic, and I set those equal to 0. Because I set those equal to 0, I'm just going to put little lines through them just for the time being. And if I read the equation across, that gives me 0x1 plus x2 equals 3. The second equation has 1x1 plus no x2's plus no z's equals 2. So I have x1 equal 2 and x2 equals 3. And then the third equation has 0x1 plus 0x2. Whoopsie, that's a mistake. That should have been 1 here, so there should have been a 1 there. That was my fault, sorry about that. So I have 0x1 plus 0x2 plus z equals 48. So I have 48 right here. Notice that that's the answer that we found when we were doing it graphically. Going back to the previous page, we found our max to be 48. Where did it occur? When x1 is equal to 2 and x2 equals 3. So how am I going to figure out what the solution to the minimization problem is from the matrix? If you remember from our graphical problem, we know that the answer from the max problem is the same as the answer from the min problem. It's going to be 48. And if you looked back at the graphical solution, we know that the answer was 4, 1. So y1 was 4 and y2 was 2. Where would you find those values? Well, it turns out that those values turned out to be in the slack variables of the maximization final simplex tableau. So the 4 right here is the answer to your y1. And the 1 happens to be the answer to the y2. And my slack variables are the zeros from x1 and x2. Notice that this solution, 4, 1, with a minimization of 48, is the same solution we found graphically, 4, 1 with a min of 48. So we can now not have to graph it, we can just change our minimization problems into maximization problems and then use the simplex method to solve.